Hi, everyone. Let's conclude section 5.2 with strategies or toolbox tools that will help you in both 5.1 and 5.2 when you simplify trig expressions and verify trig identities, which can be thought of as harder simplification problems with harder expressions where you're given the answer. Okay, so a summary of strategies. This is not a comprehensive list, but it's a good toolbox. So for a verification problem, you usually start with the larger, longer, more complicated side and trash compact it down to the shorter, smaller side. That's usually the way it goes. Although sometimes you do go from smaller to larger. For example, with the trig conjugate trick we'll discuss later on, that sometimes happens. But that is a last resort, though. It's usually easier to shrink something than to blow it up. Aim for the target. So let's say that you start with the left-hand side, target and aim for the right-hand side. That would have made my first problem a lot easier. That was my solution 4, which I presented first. Aim for the target. If your target has cosecant and cotangent, try to get cosecant and cotangent in your expression as soon as possible. Third, be prepared to apply the fundamental identities. You probably will have to. So keep them in mind. Reciprocal, well, let's review them, right? In order, probably reciprocal, quotient, then probably Pythagorean. Even, odd, or negative angle, and the cofunction identities. So these 5 categories. And be prepared to apply them step by step and carefully. It's okay to work on different pieces of the same expression, but don't do too many steps. Don't do too many things on one piece, one part of the expression. Then you want to separate your steps. When working with fractions, especially when you're adding and subtracting fractions, be prepared to use LCDs, least or lowest common denominators. They also help when you're simplifying compound fractions, like blah, blah, blah plus blah, blah, blah over blah, blah, blah plus blah, 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 or maybe with minus signs. Trig conjugates. Because squares of trig functions can help you apply Pythagorean identities. It's usually helpful if you have partners in the same Pythagorean identity in a given expression. For example, sine and cosine, or tangent and secant, or cotangent and cosecant. Maybe 1 or -1 might be involved as well. But in a way, it's kind of a last resort as a strategy because you tend to make the expression more complicated, and students might overuse the strategy on exams, actually. So think about it, look at the expression, and see if a Pythagorean identity might eventually be appropriate. Again, these pairs of trig functions might be signals, or maybe a 1 or a -1. Okay, and then we have more algebraic strategies, like decomposition strategies, breaking things apart, going to sine and cosine, breaking things down to pennies and nickels, and then trying to construct something from out of that. Keep the target in mind. Now, that might be a good all-purpose brute force strategy, but it may not lead to the most efficient strategy, as we saw in my first example for this section. Factoring. Factoring's still legal, keep that in mind. You might want to do snap substitutions, or actually write them out. Actually write out stuff like x squared plus x squared y squared, and see what factors out. Okay, so do a snap or explicit substitution, and factor. Splitting a fraction. If you're doing it in the context of multiplication and division, we're thinking in terms of factoring or peeling. For example, and you do this a lot in calculus, cosine of theta over sine squared theta can be written as cosine of theta over sine of theta times 1 over sine of theta, where you're breaking apart the bottom. You could, of course, reverse the order. Again, keep the target in mind. You can also split a fraction through the numerator if you have addition or subtraction. For example, remember this kind of rule. You can break a fraction through the primary plus and or minus signs in the numerator. That could help. So if your target has more than one term, that's a strategy you might want to apply. Keep the target in mind. Remember, though, that we do not split through the denominator. For example, if you see something of the form 1 over x plus y, I would not recommend a splitting strategy. Some other strategies. The idea of a template. And I did this back when I discussed factoring, all right, a template, like factoring, for example. How do you factor something like this? How do you factor x squared plus y squared? Things like snap substitutions. Be prepared to look at a similar problem in Algebra 1, like a template. That could help with factoring, when you're manipulating fractions, and so forth. In general, be neat, show work, show things step by step, and don't apply more than one identity to the same part of an expression unless you separate out the steps first. Don't do too much on one piece of the expression. Otherwise, you have to separate your steps. Make it clear when you're applying each fundamental identity, so you're not smushing things together. And also overall algebraic strategies, like multiplying by something over something, like a trig conjugate. Or if you're in the process of simplifying a compound fraction, and you're using, say, an LCD. And strategy number 12, which I discussed in my best solution for the first problem in this section, internal consistency, making pieces look like each other, and also aim for the target. That's also a good combination rule, internal consistency and aiming for the target, which helped us a lot in my solution 4, which was the first solution I presented for that first verification problem in 5.2. Okay, next up, we're going to solve trig equations, 5.3.